Dear colleagues, allow me present you the results of our work named Conceptual Model of Process Formation for the Semantics of Sentence in Natural Language. Our work is a joint work from two universities, from Vinnytsia National Technical University and Lviv Polytechnic National University. It is a team of authors. The purpose of article. In our article, we consider the use of generative grammars in linguistic models of sentences in order to analyze complex sentences. We show how to use generative grammar apparatus on several examples coming from natural language, English, German, Russian, and Ukrainian sentences. And also we propose algorithms for linguistic analysis of textual content. First of all, a couple of words about generative grammars and their classifications. Usually, generative grammar G is a quadruple having such components as V, the dictionary, T is terminal units and S the initial states, and the P is the set of production rules from one chain of terms to another chain of terms in V, in a dictionary. In the literature, the grammars are classified by product types, like G0 grammar is an unbounded grammar without any restrictions and limitations. G1 is context-dependent grammar when the meaning of a chain of terms depends on the previous terms in the chain. G2 like context-free grammar when the meaning of a terminal is does not depend on context, and regular grammar which additional limitations are imposed on productions. So we have 4 types of different types of grammar, and next time is every next type is simpler than previous time, simpler to handle. In our work, we discuss the usage of context-free grammars, it means G2 grammars, to model natural text. We show that in most cases, the natural language can be modeled using context-free G2 grammars. However, it is worth to note that context-free grammars cannot be used to represent discontinuous components, like components shown in this example. For example, наша мова, як будь-яка інша, всегда унікальне місце. You see that there are dependence between two not adjacent, not two continuous words. The same is this English language example. This can be somehow remedied by using sequential consecutive right or left subordinations, which makes it impossible to represent natural language discontinuous statement. This sounds artificial in most cases, not natural. It was also shown that grammar G2 context-free grammar with limited memory is equivalent to regular G-free grammar. Another result of our work is a rather complex algorithm of linguistic analysis of textual commercial content. This algorithm has a number of auxiliary algorithms I will talk about later. So the main idea of this algorithm is sequential processing of content. We label it as C1, C2, C3, C4. C1 is initial content, C2 is textual content, so we have this initial content, we remove all non-textual part from it and obtain C2 textual content. Based on this textual content, we produce keywords, a set of keywords. And lastly, in our last stage of algorithm, we produce rubricated content, that is highly structured content, Let's go over these algorithms. In section one of this algorithm, we do grammar analysis of textual content C2. We divide this textual content into sentences in paragraphs. We find the textual chains in this content. We remove non-textual content characters and analyze the linear sequences of words. Next, in section 2, we make morphological analysis of textual content. We identify the basic form of words, identify the grammatical categories for each word form, genus, case, pronunciation, and form a linear sequence of morphological structures. In section 3, that is much more the most interesting part, we base it on this textual content, the number of terminal words or terminals T, a number of tokens U, K. We produce the set of keywords C3. And in section 4, we made semantic analysis of this textual content C3. We correlate those keywords with semantic vocabulary classes. We generate of the ordered set of superposition entries from basic lexical function and semantic classes. We verify those keywords using dictionary. In section 5, we make reference analysis for the formation of interface unities. We make contextual analysis of text commercial content in C3. We resolve local references. We make thematic analysis. We distinguish semantic structures and typical sentences, for example. We determine the regular repetition, synonymization, renomination of words. In section 6, we proceed with structure analysis of textual content C3. We identify the basic set of rhetorical connections between content unities. And we build a model of our content as a unity network. Algorithm 2 is auxiliary algorithm allowing us to provide syntax analysis. It includes the identification of content tokens and based on this create a parse tree from textual content C2 and based on this information provide the set of keywords C3. This set of keywords is filled into the content search engine base in the database. In this slide, we show the use case diagram for keyword discovery process. It includes the author who introduced a fragment of text and a moderator who moderates this process, basic operations like context analysis, fragment analysis, the base of using base of terms and morphemes, using term analysis, and generative grammatics, which is used to build and analyze the phrases, the sentences, the fragments of text. The third algorithm is a rubrication algorithm, which provides us in more fine grain the analysis of our keywords, that is content C3. We divide the commercial content C3 into blocks and We further divide these blocks into sentences, preserving the structure of content C3. Next, we divide the sentences into tokens and identify the topic of commercial content. At the end, we are filling the search engine base with such attributes as topic, category, location, keyword content coefficient with statistical significance on terms, and other metrics for this text. As a conclusion, I would say that the article discusses the known methods and approaches of using automatic processing of textual content, using grammar, context-free and regular grammars, generative grammars, highlights the shortcomings and benefits of using existing approaches, and also the algorithm, the detailed algorithm of text processing was developed and presented in our contribution. This algorithm can be used for automatic analysis of commercial text, for enhancing search queries, the detection of publication on similar topics, and other.